and welcome back. My name is Shamiria White, and today I'll be presenting a Cyber Operations and Risk Management briefing on behalf of the United Kingdom Cybersecurity team. The members of this team include Hartwell Edja, Jennifer Kim Roman, Reynalda Servin, Clement Tanji, and myself. The purpose of this briefing is to present the results of our research into the software and supply chain risks facing the organization. We will also present our recommendations to senior management for mitigating these risks to the network. The organization needs to be able to know that it's using software that is secure on its networks. Software assurance is the confidence that the organization is using software that has been verified to be secure. Several vulnerabilities exist within the software used by the enterprise. These include several common vulnerabilities and exposures, or CVEs, including the following. CVE 2018-13379. This vulnerability affects the virtual private networks, or VPNs, that users use to connect to the organization's network. It can allow a malicious actor access to the network by compromising the connection between the client device and the network. CVE 2021-26084. This exploits a vulnerability within the Atlassian Confluence Server and Data Center product that can allow an attacker to execute arbitrary code on a system without needing to be authenticated. This is a popular product used by many government agencies and private companies, including ours. CVE 2021-34473, CVE 2021-31207, and CVE 2021-34523. All of these vulnerabilities, known as proxy shell, exist within the Microsoft Client Access Server used by Microsoft's Internet Information Services web server. These vulnerabilities can allow the execution of arbitrary code and can affect users connecting to the Microsoft Exchange email servers used by the organization through their web browsers and mobile devices. CVE 2021-40539. This vulnerability exists within Zoho's Add Self-Service service, which is used to provide identity and access management services to the organization. It allows an unauthenticated attacker to execute malicious remote code. This is possible due to the service's use of an outdated third-party dependency. CVE 2021-44228. This vulnerability is more commonly known as the Log4Shell vulnerability. This vulnerability exists within Apache services that use the Log4j library, such as Adobe's ColdFusion, Atlassian's Jira Server and Data Center, and some of Cisco's network devices. These are all products used within the organization. This vulnerability can also be exploited using an arbitrary code execution attack. This can allow an attacker to gain complete control of a system. For certain projects, the organization may need to develop its own software products. To do this, it will need to follow the Software Development Lifecycle, or SDLC, which usually consists of 7 phases. These phases may change depending on which model or methodology is used, but in general, each follows these basic phases. The first phase is the planning phase. In it, the software development team must determine the scope of the project, as well as a general timeline for developing it. Next is the requirement analysis phase. In this phase, the development team gathers the customer's requirements for the project and discusses any constraints or limitations that may affect the development process. A software requirement specification document may be created in this phase to keep track of customer requirements and the resources that will be needed for the project. After that is the design phase, in which the team will determine how best to architect the software. This phase may involve creating several prototypes to help determine which one will best meet the customer's needs. Next is the development phase. In this phase, the team builds the application according to the designs of the previous phase. This is one of the most time-consuming parts of the SDLC. A form of basic testing called unit testing will typically be used in this phase to make sure that individual components within the application are working correctly. Once the product has finished being developed, it will move into the testing phase. During this phase, the software is tested to make sure that it works correctly and has no exploitable vulnerabilities. Testers can use automated tools in this phase to help it go faster, although manual testing such as source code review will still need to be done to ensure that the code is secure. After testing is complete, the product will be moved into the deployment phase. The software will enter a live environment in this phase and will be able to be used by users on the network. Some deployments divide this step into two steps, pre-deployment and live. In pre-deployment, the software is tested in the production environment first to ensure that it works correctly. Afterwards, it is fully pushed to production environment in the live step. Finally, the product will enter the operations and maintenance phase, where it will be monitored and maintained until it reaches the end of its life. Any features that are not working correctly or vulnerabilities that are found will report it back to the development team, who will fix the issues and release a patch for the application running in the production environment. There are a few models that the organization may consider using. The waterfall model is one of the oldest software development methodologies. It includes a linear workflow for developers to follow that does not allow them to return to previous phases if issues are found in later ones. It is often used for smaller projects where requirements do not change after they are initially set. The spiral model is a risk-based methodology that, like the waterfall model, follows a fairly linear structure. A specific set of risks are assessed in each cycle, and cycles are short and iterative. They can be repeated as much as necessary to address the risk found or fix issues found later in the process. The Agile methodology is one of the more popular software models being used today. It is an extremely flexible methodology that emphasizes customer requirements and feedback over a fixed structure. Developers can revisit previous phases if they need to add or revise customer requirements, fix issues, or conduct more testing. The Rapid Application Development, or RAD model, focuses on developing a working prototype for the customer that meets their requirements. This can result in reusable components that developers can use to reduce development times and ensure fast delivery of the product to customers. Extreme Programming, or XP, is markedly different from other development methodologies, and that is developer-focused instead of product or customer-focused. XP focuses on producing high-quality software while also balancing the workload among developers. This methodology can be used even if the customer does not have a clear understanding of their requirements. The last development methodology discussed, Joint Application Development, or JAD, is an iterative approach that focuses on developing details very early in the development process. Customers are included in the design phase, and their feedback is incorporated into the development build. This process can be costly and time-consuming. Capability Maturity Model Integration, or CMMI, is a way for the organization to measure and evaluate how well the software methodologies they are using are working. It has 5 levels. Level 1 is the initial phase, in which the organization has no set processes or poorly designed ones in place for software development. This presents a great risk to the organization. Next is Level 2, the managed phase. In this phase, some projects include planning and documentation, but it's not a standardized process. The risk is lower than the previous phase. Once the processes become more well-defined, the organization will enter Level 3, the defined phase. In this phase, the processes used to develop projects are standardized, and clear and complete documentation must be included in each one. The products created using these processes are of higher quality, and the risk to the organization is lower than in previous phases. The organization reaches Level 4, the quantitatively managed phase, when it starts using quantitative measures to gain a deeper understanding of which processes are working within the organization and which are not. Both the process and the product are evaluated for performance and quality to determine if the standards are being met. This helps to create much higher quality products and decrease risk to the organization. Level 5, the optimizing phase, is the highest level than the CMMI maturity model. In this phase, the organization is continuously monitoring their processes and products for quality issues and potential risks. The organization moves towards incremental improvement as well as innovation in their management of current processes. Only the highest quality of processes, standards, and deliverables are accepted, and the risk to the organization is the lowest of the 5 phases. Another important aspect of risk management is monitoring for issues within the supply chain. Supply chain risk management, or SCRM, can help the organization to identify, address, and keep track of potential threats to hardware and software obtained from third-party vendors. For example, attackers may try to install malware on the firmware running on hardware devices before the organization ever receives them. Or they may try to exploit vulnerabilities on a new piece of software that was obtained by using default account credentials or finding default open ports that can provide them a way into the network. Several recommendations are presented here to address the previously discussed risks and concerns. To help mitigate software vulnerabilities, the following solutions should be implemented. Vendors, designers, and developers should follow a secure by design approach to developing software. This means adding in security features to a software product at the start of the project instead of trying to fix such issues after it's completed and in operation within the production environment. Software products should also have a secure by default configuration. This means that they're securely configured from their initial use. For example, a hardware or software firewall device being added to the network should have no open ports or services running aside from those necessary to manage network traffic. A patch management system should also be used to help keep software and systems up to date. This should be implemented in addition to security tools such as network protocol analyzers, endpoint detection and response systems, and web application firewalls. An effort should also be made to understand how security is designed into software products supplied by third-party vendors. This will help the organization to determine which products will meet their needs when it comes to security as well as functionality. The organization also needs a software development methodology that aligns with its mission goals and produces a secure product. Of the software development models discussed, the recommended one for the organization to use is the Agile methodology. This methodology will encourage collaboration between the project stakeholders and the development team, and it will enable the organization to develop the software that it needs to in a timely manner. Any changing requirements can be quickly integrated into the development cycle without disrupting it, and risks can be addressed at any phase of the life cycle. Other recommendations for handling security within the SDLC include incorporating security into every phase of the SDLC. A risk assessment should be conducted at the very beginning of the project, and at every stage, risks should be reassessed and addressed instead of waiting to do so later in the life cycle. Senior management and stakeholders, such as the Information Systems Security Officer, or ISSO, should be aware of the possible risks that new software may introduce into the network, as well as which controls would best protect against them. Developers should incorporate secure development practices into their projects as well, such as using a secure by design approach and making sure that user input is validated by including input validation and boundary checking safeguards in the application code. And lastly, the supply chain needs to be protected just like the rest of the organization's network. A few good practices to follow that will help the organization manage supply chain risks include ensuring that senior management is involved and supportive of SCRM activities within the organization. They must have oversight of the program and help manage it and make risk decisions. The SCRM should also be considered as a lifecycle process that needs to be addressed at every stage of a hardware or software's development. The proper controls should be implemented to monitor, identify, and respond to potential supply chain risks. The organization needs to keep track of which vendors it's using and the vulnerabilities that may be associated with their products. Any new vulnerabilities found should be addressed as quickly as possible. Assets should also be protected from physical tampering. and the organization should have specific clauses in place to ensure that this happens in their contract with the vendor. And finally, the organization should use information sharing platforms such as Information Sharing and Analysis Centers, or ISACs, to make sure that it stays up to date on the latest threats and risks that it could face. And with that, this concludes our briefing on the software and supply chain risks facing the organization. Senior management is encouraged to review the recommendations presented in order to make informed decisions regarding the security measures that need to be implemented on the network. Thanks for listening to this report, and as always, we hope this briefing has been informative. Until next time, this has been the UK Cybersecurity team.